So the next metallurgy technique that we will be talking about is in chapter 14. It is sand casting. Casting is the forming of metal by pouring molten metal into a mold. The metal is then allowed to cool and solidifies, and it takes the shape of whatever that mold is. So here in the shop, what we do is use aluminum. We make patterns, use those patterns to make molds, and then we pour in molten aluminum, and our aluminum takes the shape of that pattern and gives us our sand casting. So in the casting process, you start with a pattern. And the reason why this lesson is falling where it is, and why it's a general information lesson, is because we need to start with a pattern. You need some background information on how to make that pattern, so then when you come into class and it's your day to cast, everything's prepared for you. We use our 3D printers to create patterns for casting. Part of this unit will be learning how to use computer-aided design to draw something on the computer, send that file to a 3D printer that turns whatever you want into reality. We'll talk about patterns a little bit more in a second, but we have some more general information to go over. So, casting. The oldest form of casting that's controllable is sand casting. Sand casting means that the medium that we pour into is sand. If you were to think back whenever the last time you built a sandcastle was, you need to gather up some sand, put it into a pail or a bucket, something shaped like a castle. And then it takes that form. And if you think about that sand, you couldn't grab the top layer of sand that's been drying out all day, and you couldn't grab sand that was just at the bottom of the lake. You need sand that's kind of damp, somewhere in the middle. And that's the same thing here. The sand that we use here in the building is called green sand. Green sand is a type of casting sand that is more eco-friendly. It's better for us as the humans who are using it. It's a combination of sand, bentonite clay, and water. And the water is pretty important. This goes back to figuring out the right consistency for building your sandcastle. You want to have just enough water. You don't want too little, you don't want too much. One of the reasons why you don't want too little is the sand, when you try to create that mold, will be too dry, and it won't take the shape of whatever pattern you put in there. And you want it to take the shape so it comes out accurate and looks nice and pretty. On the other end of the spectrum, you don't want it too wet, because if the sand is too wet, well, one, it doesn't hold the pattern as well either. But also, we're pouring molten metal into this cavity, this mold. And we're using aluminum. So aluminum melts at over 1200 degrees Fahrenheit. So this is incredibly hot material. We want to keep molten metal away from water at all costs. When they combine, there are issues. One of the big issues is that the water flash boils. So it's whatever temperature it is, it comes up to a boiling point and expands rapidly and can cause an explosion. And then you have pieces of molten aluminum flying all over the shop. And that is incredibly dangerous, and we're going to try to avoid that. So, like I said, we want that green sand to be in the Goldilocks zone of dampness. We don't want it too dry, we don't want it too wet. So there's a few different techniques to figure out if it's close, and you'll learn about that in the next lesson. But also, I'll always come over and check to make sure that we're not going to have any safety issues. So how do we melt down this aluminum? Well, over in the corner we have our foundry, and we use our furnace over there to melt it down, and it goes up to over 1200 degrees because that's where aluminum melts. we can't just put a chunk of aluminum in there. We use something called a crucible. And this crucible is made out of graphite, a graphite compound, similar to your pencils. We use graphite because it can withstand very, very high temperatures. But there is a downside. Graphite is relatively fragile. So over time, we have, this is a used crucible. This was used at Oakmont for many, many years. It had hundreds of heats where we put aluminum in, we bring that up to an extreme temperature where it melts into molten aluminum, and then when we're done, we turn off the furnace and it cools back down. Warm metal expands, cool metal contracts. Expands and contracts. And when you have years and years of molten aluminum inside of this graphite crucible expanding and contracting, eventually it will cause a crack. Now, we got our money's worth out of this one, but also a crack could happen if we are not careful with the crucible inside of the furnace. When we put aluminum into here, we carefully place it in with tongs. We do not just throw it in there like a three-point shot. We have to be careful with this. It is fragile, but it's very useful. Again, this is our graphite crucible that goes inside the furnace. So let's take a minute to talk about the patterns. Here I have a couple of 3D printed patterns that some students have made in the past here at Oakmont. Before we had a 3D printer, we made everything out of wood. The students cut out their shape with pieces of wood. They could stack up multiple layers. And you'll see that here, this Boston Red Sox logo is a great example. There are 2 layers here. You can see the top part of the sock is lower. The toe and the heel are lower down. It's white on white, so it might be hard to see the contrast, but the camera should pick that up. And then also there's the line in between. These raised and lowered sections, when we take our final casting out, will show those different heights and give us the details that we want. An advantage of using a 3D printer to create the patterns is that you can design a lot more detail than you might have been able to with a wooden pattern or something like that. Now, the details can be tricky. Here on the Metallica logo, that small little centerpiece of the A might not come out in some castings, and that could be because of the sand. Maybe it's not the right water to sand mixture. And also, there's something called draft angle that plays a big factor in this. Now, draft, if you think back to your sandcastle adventure, the bucket that you're using that's the pattern for the castle, it's not straight up and down on the sides. It has an angle that goes out. So as you pull this pattern up off of the sand, and it gives it the ability to be removed easily. So when we create patterns, we engineer that angle into our pattern so that our mold will have that shape, and it's easy for the pattern to come out of the sand to create a nice, even mold for the metal to go into. This was another 3D printed pattern. I think it was National Guard or some. It's a military thing, and you'll see that the difficulty goes up here in the detail. And unfortunately, this one was a bit too detailed, or it may not have had enough draft angle, because when we went to pour it and cast it, you'll see that those details just did not come out. So there is a fine line between how detailed you can go. All of these are called simple patterns. Now, some are more complex than others, but they are all simple patterns. And the reason why they're simple is because they are one-sided. On the back here, they are all flat. We are only going to create a cavity on one side and pour in. This Abe Lincoln casting, again, is very detailed, pretty complex, but is a simple pattern because there's nothing on this back side of the face. You notice this one was pretty much just pulled, still has this stuff attached, which we'll talk about in a minute. What happens if you have both sides of a pattern? Well, then it's called a split pattern because it's split right in the middle. When we talk about engines, a lot of the parts in a small engine are cast, and you'll see a line running down the middle, and that's called a parting line. Here we have a split pattern. This is on one side of the wood, and this is on the other. This piece of wood is in the middle to hold it up, and you'll see how we use wood when we do the actual demonstration of it. But this would, in fact, create the parting line. Now, what is this? Well, when it comes out, it's a C-clamp. So if a split pattern has things on both sides, and a simple pattern is only one-sided, nothing on the back side, it's a simple pattern. Doesn't look very simple, there's a lot going on. What this is a pattern for creating nuts, like little nuts and bolts for tightening. You can see all these little hexagons. And this is a great demonstration of what's called a gating system. When you pour the molten metal, it has to get to everywhere in the pattern. Pour it in one section, it has to flow all the way through, and it also has to allow the gases that are in that cavity out. So here, all of these little channels allow the metal to flow to the individual parts, nuts in this case. In our split pattern of the C-clamp, that does the same thing. There's little wooden dowels that create a gating system for the metal to get to the part. Back to our friend Abe here, that's what we have. This was cast in our shop, pour in here, goes through the gating system to the mold. It's empty at that point, and then the aluminum comes back up just to make sure that we cover everything. Now, I keep saying in the sand, when we cast, how do we contain all of this? What I have right here is called a flask. And the flask is in two parts, and you can see the two names, the cope and the drag. The cope is at the top, the drag's on the bottom. And they separate. What we do here is over in the foundry area, we fill the drag with sand, put our pattern in, pull the pattern to create that mold. Then, with the cope filled with sand, we have our gating system installed here. And then we can pour everything into here. This sand allows the metal to cool on the inside and allows us to create a casting. Now here at Oakmont, what you cast is up to you, and it's also just going to be sort of like a decoration piece, right? We are not casting any parts to be used in machinery or anything. So we don't really care about what's called the shrink rule. As metal cools, it shrinks. As it heats up, it expands. So in industry, when someone creates a pattern for a part that will be used later on when it's poured and made out of that metal, the pattern is actually slightly oversized because then they can machine it down, especially on bearing surfaces, which you'll see in engines later on. But also it accounts for the shrinkage of the metal as it cools. So this was a lot of theory on sand casting, talking about patterns, where we have simple patterns and split patterns. We talked a little bit about how we actually melt it down in the crucible in the furnace. And then also the flask, where we contain everything, like the pattern to create the mold, in the sand, the green sand in our case. There will be another demonstration lesson on how to actually ram up a mold in on this flask. But first we have to go a little bit into the CAD and 3D modeling area. So then you, yourself, have the knowledge to create something like this Metallica logo. You can do whatever you want, as long as it's school appropriate, and print it out to make a pattern, to ram up a mold, and pour in molten aluminum. If you have any questions on casting, please feel free to reach out. I'm happy to help.